In the second half of the section 4.6, we will be learning to solve absolute value inequalities. In the before, absolute values was distance away from zero. And so in this case, in the absolute value, we're looking at absolute value of x where the distance is less than 3. So what we can say is if we're looking for the distance away from 0 is 3 or less, so 3 this way or 3 this way, okay? All the numbers that are between -3 and 3 are distance of less than 3 away from 0. So if I were to graph this, I'm looking for all the numbers that are between here that are distance of less than 3. So we could take the absolute value inequalities and write it as a compound inequality. So in this case, since all the numbers are between here less than 3, distance of less than 3, between -3 and 3, I could rewrite this and say x has to be between -3 and 3. So absolute value of x means how far, what are the numbers that has a distance of less than 3, and all the numbers are between -3 and 3 if I were to graph this. So in this case, when you see an absolute value by itself like this, and it's less than, this is an and compound inequality. Now if I had an absolute value of x, which I want to look for distance that are greater than 3, so that I'm looking for all the numbers that has the distance of greater than 3 away from 0. So here's 0, and here's -3, and here's 3. I want the distance to be greater. So if this up to here is 3, I want all my distances, all the numbers that has a distance of 3 or more, because that's 3 to here this way, and 3 this way, and 3 this way. So then if you notice, these numbers are either all less than -3 or all greater than 3. So if I had an inequality that has a distance, absolute value of x, that has a distance of greater than 3, then I could express this as an OR compound. So this would be represented as x is less than -3 or any numbers that are x is greater than 3. So this is an OR compound inequality when I'm looking for distance greater than 3 or greater than or equal to. So this is what we're going to be doing to solve absolute value inequality. So in your book, example number 3 is to solve and graph. So absolute value of x minus 5 is less than or equal to 2. If you notice, I have the absolute value by itself, and I don't have anything on the outside. And I want to know what numbers that would make these numbers be 2 or -2, like with the absolute value inequality, with the equations. So now we're going to take this number, x minus 5, and I want that to be less than or equal to 2. And this time, I want this x minus 5, I want it to be -2. But in inequalities, if we change the sign, we must flip the inequality. So we're going to solve like we did it before. So we're going to add 5 to both sides. And x has to be less than or equal to 7. And when we add 5 to both sides, x has to be greater than or equal to 3. So if I were to graph this on a number line, 3 and 7, this one, x is greater than or equal to 3, so it goes this way. This one, x is less than or equal to 7. So all these numbers were the numbers that would, if I plug it in, would make my distance less than or equal to 2. So because this is an and, we got to rewrite our answers as a compound and compound inequality. So we're going to write it like this, where x is greater than or equal to 3 and x is less than or equal to 7. And this will be an and. Let me give you another example. Solve and graph. This time let's make it 2 times the absolute value of x minus 4, and I'm gonna minus 3, and I want that distance to be greater than or equal to 5. So like what we did with the absolute value equations, we want to get the absolute value by itself. So what we're going to do is we are going to add 3 to both sides. And I got 2 times the absolute value of x minus 4, and that is greater than or equal to 8. And then to get this by itself, this is multiplying, so I got to divide by 2. So then I got absolute value of x minus 4 is greater than or equal to 4. So what I'm looking for are numbers that would be distance of 4 or greater from 0. So what numbers would x be so that the number together here would be distance of 4 or greater? So now we're going to split this again. We got x minus 4 is greater than or equal to 4, and then this one, same thing again, except now we're going to make it negative 4, so we got to flip the sign, which makes it less than or equal to negative 4. So we solve it again. So then we got x is greater than or equal to 8, and then when I add 4 again, x is less than or equal to 0. So these are the numbers when I graph. So I have 0, I have 8, x is less than or equal to 0, so I'm going to plug it in. I mean, it's a closed circle, and it's on the less than side. And this one is x is greater than or equal to. So what it's saying is all these numbers on the less than side of 0 and greater than side of 0 would make that equation have the distance of greater than 5. And this is an or because it's going in the opposite direction, so you need to put the word or in your answer, and that's how you solve. Now, last type of question that absolute value is used is in the word problem, where in real life we deal with measurements. So in example number 4, we have a situation where we have the ideal measurement. So what we want the measurement to be, so ideal diameter of a piston for one type of car is 88.000 centimeters. This is an ideal measurement. But you know, as being a human, we can't make it, you can't measure this accurately, so the actual diameter can vary from the ideal by at most 0.007 centimeters. Actually, let's make it millimeters. Millimeters. We want to find the range of acceptable diameter of the piston. So what do I want it to be when I measure, and I gotta be off by at most. So this is what's telling me how far away from 88 can I be. So when you write your inequality, absolute value inequality, it's going to be actual measurement that we want it to be minus the ideal measurement, and this has to be at most, right? At most, the distance between the actual and ideal, the difference between them has to be at most 0.007 millimeters. So now when we put this together, what we're going to do is, we got the actual, we don't know. What is the acceptable? So this is X. And my ideal measurement is 88.000. And at most, remember, is less than or equal to 0.007. So now when we solve this, this will give me the range of acceptable measurements. So remember, I want the inside to be either 0.007 or I want it to be negative 0.007. So we're going to split this up. X minus 88.007 has to be less than or equal to 0.007. And I want the inside to be X minus 88.000, and I want it to be negative 0.007. So then, because I made it a negative, I must flip greater than or equal to. So now once I solve, plus 88.000 plus 88.000, X has to be 88.007, so I could be off by 0.007 in the positive direction, or if I add this, and I add 88.000, remember you're going to line up the decimals when you subtract, my X has to be greater than or equal to, and then when I subtract this, I get 87.993. So my measurements could be between. So now if I were to write from least to greatest, X would be in the middle. And then X has to be greater than or equal to 87.993, which is less than or equal to 88.007. So this is my acceptable measurements for my piston to meet the requirement of 0.007 millimeters. So we've talked about error before, and this is what we're talking about. We could be off by 0.00 millimeters, and I want to know what those measurements are. And this tells you that this is that plus or minus, right? Plus or minus. I could be off by this, and it's expressed in an absolute value inequality. So remember, when you're doing this type of problem, it's actual minus the ideal, where actual is your X. Ideal is the measurement that's given, and then I want to be off by at most, or vary by at most, this number right here.